Hello, everybody. I would like to go through one problem from chapter 13 of your textbook. It is problem 13.78, and I would like to go through that. The very first thing I'll do, I'll make sure I read the problem carefully, and I would like to find out, based on what the problem says, what would be my y variable and what would be my x variable. In simple regression, we have to identify our y and our x. In this case, the idea is to predict the grade point average (GPA) of student in an MBA program based on graduate management admission test (GMAT) score. So right now, by reading this, I would know my predicted uh, variable would be GPA, and that's the one I want to predict. And the one I got to use to predict that would be GMAT. So my Y would be GPA, and my X would be GMAT. So let me go to StatCrunch and try to use this one. As long as you have a Mac computer, I think this is your best option. So let me go to the StatCrunch and try to retrieve the data. The data is from chapter 13. So let me go to data set. And when I'm looking at the data set, it says the name of the file is GPIGMAT, GPIGMAT, right here. And so I'm going to retrieve the data and try to use StatCrunch. And so it put the data right away in front of me. And the very first thing I'll do when it comes to regression, I have to plot the data. So let me go and use a scatter plot. And I have to identify my x and my y. My x variable would be GMAT, and my y variable would be GPA. I need a point display, and I need a label. Say this one is GMAT score, and this one is GPA. And next, and lastly, I create the graph. Uh, it's very important to look carefully at this graph and look for kind of pattern. See if there is any kind of pattern here. Here, my intention is to fit a straight line. So if the straight line fit here it looks to be okay. And let's see how it's gonna go. So let me save what I have. I'm gonna save this to my computer, and let me put it in a proper place. Let me put it on my C drive in my case, and let me do it for the put it in a folder for this course. So I'm gonna just say first plot y versus x and save it. Now let me now go and try to use a start and try to run a regression on these data. So I go to start, I go to regression, and I go to the simple linear regression. Again, I have to identify my x and y. My x obviously is GMAT score. My y is GPA. And I want to through this. It gives me option to use it for test of hypothesis uh, or use it for confidence interval. Unfortunately, it doesn't give both of them at the same time. If I choose confidence interval, I cannot use the test of hypothesis. So I can do it in two steps. It can test for equality of y-intercept to 0, also equality of slope to 0. This is more important, equality of the slope to 0 or against alternative uh, slope is not equal to 0. I could change it if I wanna, but usually uh, we are testing in this class just in simple and multiple regression for slope either equal to 0 or not equal to 0. Now, let me continue. Uh, it tells me, okay, I can predict y value for given value of x. When I read the problem carefully, I find out in part C they're asking for what happened when somebody got a GMAT score of 600. What happened to that person's GPA? I want to predict that. Furthermore, I think in other parts, let's say part G and H, also they need a confidence interval. So I'm going to put this information here. Furthermore, I ask for saving residual and saving fitted value, and I continue. Now, I would like to come up with predicted line. I would like to look at the residual for further analysis and look at the fitted value of residual, fitted value against residual. So let me do this. And obviously, this is okay. And now let me do calculate the whole thing. It's going to go through and come up with the output. Let me enlarge it. And here, when I'm looking at the top of my file, it says dependent variable is GPA. That's exactly what I was looking for. Independent variable, my x value variable is GMAT. And then it says, okay, if you're interested in predicting GPA, this was the equation you need. 0.303233 plus 0.00487, let's say multiple by GMAT. I guess you need as much as this small point in this case as you can carry, and StatCrunch provide you that. It tells you sample size is 20, or correlation coefficient is 0.8932. And this one actually measuring the how strong relationship between the two variable R's, in this case the relationship between GPA and GMAT. Then it comes up with R squared, which is square of R. It is 0.7978. This one tells us what portion of variation can be explained or can be reduced by using simple linear regression in this case. So it's roughly 79.78% of variation can be reduced. And furthermore, it gives us estimate of error standard deviation. That's known in your book as the standard error of the estimate. It is 0.1558. And now, if I'm interested in statistical tests for slope, I come right away here to this table. And now, the slope itself is 0.0048, and the standard error of the slope is, in your book, is known as SP1. It is 0.000577. And remember, this is a scientific notation. This is a very small value. So eventually, if I divide the slope, which is known as B1, over standard deviation of slope, which is SP1, this over this, I could come up with T of statistic, which is 8.4279. And obviously, it came up with p-value. It's very, very small, less than 0.0001. If I'm looking at your book for part F, it says if alpha is 0.05. Obviously, alpha is more than this. And if I set up the hypothesis that under HO slope is equal to 0, it means there is no relationship. Under alternative, slope is different than 0, then clearly I could reject HO. I could reject HO and say, no, slope is not equal to 0. If slope is not equal to 0, it means slope is very, either positive or negative, and obviously it means it's contributing. It means that in this case, GMAT score has a relationship with GPA, and there is a relationship between the two. That makes the model useful. Furthermore, if I look, it gives me the analysis of variance table for regression model. Again, some people, they might use that to run a statistical test, and the f-stat is 71.03, and the p-value for that is 0.0001. It's going to give you the same result for simple regression. So if I'm looking at these two, I can exactly get the same result. Lastly, as you recall, I have ask for the predicted value of GPA of a student who GMAT score was 600. Based on this model, the predicted value of GPA of that person is 3.22. And it goes through and also comes up with result for 95% confidence interval for the mean, which is something that part G of your book is asking. It's already this is what the result should be, and also give you 95% confidence interval for new value of x, which that one you may not need it at this time. Now I can easily save these again or copy and paste it. So if I save it to my computer, I'm going to save it simple linear regression result for 13.78. And I could easily copy these to Microsoft Word, or I can make it part of Microsoft Word actually. Please go through these, and if you have any question, let me know. And I'm going to assign you some problem similar to this. Make sure you follow them. Take care.